Hello! So today I'm going to be building a queue from scratch in C++, and this is going to be building off of the linked list that I created in the previous video, as a queue is in fact a specific kind of linked list. That is a linked list where we are always going to add things to the back and remove things from the front. Now before we get into any of that, I want to show you a few corrections that I made in the linked list class itself. First of all is my create and destroy functions. So instead of using malloc, I can actually put something onto the heap simply by defining a variable as a pointer, that is this new node pointer. And then I can use the new keyword to create a new object of a linked list node in that memory address. And this does in fact put something on the heap, and new actually calls the malloc function itself. So this is just a more standard C++ way of doing exactly the same thing. And the same applies for my destroy function. Rather than calling free, I use the keyword delete and pass it the pointer to the item I want to remove, and we have exactly the same functionality with a little bit simpler code. Also, I moved my iterate function into the private area of this class. And that's because the subclasses should not be manually iterating in the linked list. They're going to need to call these public functions in order to do anything like that. Finally, I added a retrieve function. Since I want the users to not have to deal with the node objects at all, I want my linked list class to create and destroy those nodes for the user, they're going to need a way to get the actual data out of a node rather than a pointer to the node object. So this retrieve function simply returns the data stored within a node. Okay, so those are all of the changes I made. You can see there are some aesthetic things I did with comments, but those are non-functional. So let's go ahead and create our queue. So create a new file, I'll call it queue. And again, the queue is going to be an implementation of the linked list. And with the linked list, I need to specify the type of data that I'll be storing in it. That's why it's a class template. But again, I'm not going to know what sort of data the user is going to want to store in their queue. So I am going to, again, need a class template. So I can go ahead and delete this C++ file and work strictly in my header file. And I don't need this standard in out, so let's just go ahead and include, not that, I want to include linked list.hpp. We're going to use our namespace as always, HDE, and we're going to declare a class. And this class is going to be called queue, and it's going to inherit from linked list. And I misspelled it up here. Now, an important thing to note about how I'm going to inherit this. So remember, by default, classes inherit from one another in a private relationship. So everything that was public is going to become private in the inherited class, or the class doing the inheriting. And that is what I want here. I want to be explicit when I do that. I want to call it private. And that is going to make it so that the user, when using the queue itself, will not have access to the methods of the linked list. I don't want them to be able to insert things randomly in the middle of the queue. They have to add things to the back and remove things from the front. That is the entire purpose of the queue. Since we've done all this work with the linked list, this is actually going to be a pretty simple class to create. All we need are a few public methods. I don't even need a constructor for my queue because the linked list is simply going to set everything to be null initially, and that's all I need in the queue. So all we need are two functions called pop and push. Pop removes the head and push adds something to the tail. So let's make our pop function first. Before that, I need to actually say that this is a template and give it the type name of t. So our pop function is going to return the data in the head. So I'm going to say t pop. The user does not have to pass anything in. And what we're going to do is retrieve the data from the head and then remove the head. So cut off the head. So we are going to first get to that data. So we're going to say t data equals retrieve and we're going to retrieve from position 0. Then we are going to destroy position 0, and then we are going to return the data. And that's all we need. That's going to take the data out of the first item, and it will send it to the user as the output of this function, and it's going to destroy the head. And we've already written this function to handle all of that. Except I made a mistake. I don't want to call destroy, because you remember destroy is one of the private members of the linked list. I want to call my delete, not destroy, because delete is a little bit more precise. So we're going to call, is it delete or is it remove? What did I call it over here? Remove. Got it wrong twice, but that's okay. So by calling remove, we will use this function in here to remove that item from the list. And that's going to handle all of the care about changing the head and making sure the memory is dealt with accordingly. So that's how we're going to do it. Next, we just need the push function. And this is going to be void. We're going to call it push. And here they are going to send the data they want pushed into the queue. So they're going to pass t data. And we are going to add this to the list. So we're going to insert that data, and we need to insert it at a certain position. And that position is going to be the length of the queue. So if we look at our linked list, we can see that we are storing length here. I think I forgot to mention that I created this getLength accessor function, and we're just going to call that. And if we look at our insert function, it's going to take the index we want. But remember that the indices are 0 based. So if we take the index that is the length of the queue, it doesn't exist. But what we can see here is that when it actually goes to put the item in, it's going to do it with the cursor pointing to the item before the index we want. So it subtracts 1 from that index, so we can in fact pass in the exact length. So get length. And that's all we need. So this is a queue. All it is an implementation of a linked list that limits our ability to do certain things. That is, we have to put things at the end of the list, and we have to pull things from the front of the list. So this is a sort of restrictive child of the linked list, and it just forces us to use it in a particular way. So this was a very easy data structure to create, and so that will be it for this episode. If you enjoyed it, feel free to leave a like on the video, subscribe to the channel, and all of that good stuff, and I will see you next time. Toodaloo.